Alright, this is question 7, homework 6. So we're being asked the maximum height of his jump. So we are given a change in h. So when we have a change of h, let's define the flat right here when he leaves the ramp as 0, or 0 gravitational potential energy. And then we know that the gravitational potential energy is mg change of h. And since we defined the end of the ramp as 0, that means he has no gravitational potential energy. So all of his energy must have been turned into kinetic energy, which basically means at the beginning, the potential energy is the same as the kinetic energy as the end. So we know the formula for gravitational potential energy, mgh, and then we know the formula for kinetic energy, 1/2 mv squared. So we set these two equal to each other. We divide both sides by m. We are left with gh equals 1/2 v squared times both sides by 2. Plug in your g and h, whatever those numbers are, and then you will find your v squared. Square root that, you find your v. Now, this is his total speed, but this question is only asking us about the height he reaches. So we need to figure out his speed in the y direction when he leaves the ramp. So when he leaves the ramp, only this part, if you will, of this vector is the y direction. So we should know at this point that if this is the magnitude, then the y direction is the opposite over hypotenuse, or the sine theta of the magnitude in this case. So the sine theta of his magnitude speed is his speed in the y direction. And we're only worried about the y direction because it's only asking about the height. So we need to find v of y, which is just v times sine theta. Plug in your numbers, you should find v of y. So now we know his or her, I guess, speed in the y direction. So it's asking about the maximum height. Well, once their speed going upwards has hit 0, gravity will begin to pull them down. Well, gravity's always pulling them down, but gravity will change their velocity to negative and their distance to negative. So we need to find how long they're in the air before they reach the really top of the peak. This is basically just a projectile motion problem at this point. So we take the vertical speed, which you found before from your magnitude speed times sine theta. You divide it by g, 9.8 meters per second, and you will find the time. So now you know the time that it takes to reach the max point. And now we can use our distance formula that we've used from beginning, which is x equals v initial speed times time plus 1/2 at squared. You have to remember this formula, or be able to derive it. So then you plug in your numbers, you plug in your t, you know your v naught. Make sure this v naught right here is in the y direction of speed, because that's the only part we're worried about. You know your a, it's negative 9.8. We call it negative in this point because we define down as negative, and you will find x. Now for b, they're basically saying this guy weighs 10 pounds, 10 kilograms more. It's the exact same thing. So okay, if this guy was 10 kilograms more, remember, we started by setting potential energy equal to kinetic energy. mgh equals 1/2 mv squared, or technically delta h, but you know what I mean. But also remember, we divided m from both sides. So throughout our whole entire work, we never used m, which basically means m just has no effect. The mass has no effect on the speed. It doesn't matter if he has a 1,000-ton rock or a piece of paper in his backpack. M is not in any of these equations, and it does not change our answer for that reason. So it's the exact same number.